I'm going to show you how to solve any first-order differential equation. Now, I'm stretching the truth there. I mean any first-order differential equation that you would see in first year university mathematics. Okay? So the general setup of a differential equation is something like this. Okay? So it might be a nonlinear differential equation, but f is some known function usually. Now, many people, when they first encounter differential equations, seem sort of view it as a battle. Okay. Now, when you're battling with differential equations, you want to protect yourself. You want to bring your shields. Okay. Now, what do I mean when I say shields? Well, it's just a way of abbreviating all the ideas and the techniques associated with first-order differential equations from first-year university mathematics. So, S. The differential equation might be separable. In other words, it's something like this. Okay? You separate the variables and you integrate. H. Homogeneous. Okay, what's a homogeneous equation? Well, it's something like this. Well, you have a special structure. Okay, in here you make the substitution u equals y over x, and then you form a separable differential equation. Now, I'll leave the I for a minute. What do you think the E stands for? Exact, right. So that's of the form, usually, where the differentials are separated and you have the partial derivatives of these m and m satisfying some sort of relationship here. By the subscripts, I mean partial derivatives. So m sub y is dm dy with curly d's. N sub x is dn dx with curly d's. What do you think the L stands for? Linear, right. Okay, so that's when the equation is of the following form. Okay, so to solve a linear equation, what you do is you look at this coefficient function of y, and you form an integrating factor, e to the integral of p of x. And you multiply through both sides, and then you use the product rule to reduce the left-hand side to the derivative of product. Okay, I'll leave D for a minute. What do you think S stands for? We've already used separable. What's another way to solve a DEs? Well, via a substitution sometimes. Okay? So you can take a very complicated differential equation, possibly a nonlinear form, and, for example, use a certain substitution to reduce it to a linear form. Okay? Sometimes. There are lots of other substitutions. Now, by the D here, I mean you can solve the differential equation directly. In other words, just by direct integration. So y prime equals f of x, well, you just integrate both sides, right? Now, I haven't talked about the I yet. There's also a technique which is similar to what we do with linear equations, called use of an integrating factor. Now, this is probably the rarest of the techniques. If a differential equation is not exact in its original form, what you can do is sometimes multiply through by an integrating factor to make it exact. Okay? So, when I'm analysing differential equations, I always think, okay, what am I dealing with? Is it separable? Is it homogeneous? Is it linear? You know, is it exact? Can I solve it through a substitution? Can I solve it through a direct integration? Or if it's not exact, can I make it exact? That's it. That's the whole first-order differential equations in first year in one little acronym, SHIELDS. It's good stuff. Anyone heard of it before? It's brilliant.